When you think of the cloud, you probably imagine a vast network of virtual machines and scalable services. But behind every cloud experience is a very real physical infrastructure. And Microsoft Azure is among the largest and most resilient in the world. In this session, you'll explore how Azure is built from the ground up, how Microsoft ensures global availability, and how data residency, redundancy, and disaster recovery are handled through a layered physical design. Microsoft Azure is built on a global network of data centers strategically located across the world. These data centers are grouped into regions, and each region consists of one or more data centers connected with low latency, high bandwidth networking. You'll find Azure regions in North America, Europe, Asia, Africa, and Australia. And each one is designed with high availability, regulatory compliance, and data sovereignty in mind. Let's break down how Microsoft organizes its infrastructure. You start with geographies. These are boundaries based on geopolitical areas such as the United States, Europe, or Australia. Each geography ensures data residency and compliance with local laws and regulations. Within a geography, you have regions. A region is made up of one or more data centers. Each region gives you access to the full power of Azure services close to your users, reducing latency and improving performance. Within many Azure regions, you will also find availability zones. These are physically separate data centers within a region with independent power, networking, and cooling. They protect you against localized failures like power outages or hardware issues. Azure guarantees 99.99% uptime when you deploy across multiple zones. Azure takes things further with region pairs. Each Azure region is paired with another in the same geography. For example, East US and West US. These region pairs are physically separated to avoid natural disaster overlap, asynchronously replicated for services like storage, prioritized during updates to ensure only one region in a pair is updated at a time, and designed for automatic failover and geo-redundancy. When you architect your solution using region pairs, you are building with resilience and compliance in mind. All these data centers and regions are interconnected through one of the largest and fastest networks in the world, Microsoft's Global Wide Area Network. It spans over 165,000 miles of fiber and provides the backbone for ultra-fast, low-latency communication across the Azure cloud. This network is separate from the public internet, providing extra performance and security for your workloads. Each Azure data center is packed with custom-built server racks, high-efficiency cooling systems, secure power supply lines, 24/7 physical security controls, and access restrictions. Microsoft continually invests in innovation to ensure sustainability, energy efficiency, and carbon neutrality, including renewable energy, water-efficient cooling, and recyclable materials. As an Azure user, you might focus on virtual machines or PaaS services, but understanding the physical infrastructure behind those services gives you a huge advantage. You make better design decisions, you improve availability and performance, you meet compliance requirements, you plan for disaster recovery and redundancy. In other words, when you understand what's under the hood, you can drive your solutions more confidently. So, what's your key takeaway? Azure is built on a global network of regions and data centers. Geographies ensure legal compliance. Regions provide localized access. Availability zones add resilience. Region pairs offer protection against regional failures and support disaster recovery. Microsoft runs its own global network backbone, enhancing performance and security. Physical infrastructure is designed for security, sustainability, and scalability. Cloud computing isn't magic, it's brilliant engineering. And by understanding Azure's physical infrastructure, you're not just a cloud user. You're an informed architect, ready to design solutions that are reliable, scalable, and globally distributed.